first slide I have for you this evening is an overall map using the county map detailing the location of Centerton Road Bridge as well as the local county roads in the area, namely Rancocas, Beverly Road, as well as Creek Road. The area in the red details the approaches to the bridge from the closest municipal street. Also detailed by that is the demonstration that the route is more or less an alternative route more than a detour. The top of the slide is a representation of the bridge. As I break into further slides, it'll detail some of the information so you'll understand, most notably the swing span and the navigation channels and the approaches. Below that is a section view of the bridge detailing, once again, the water features with regards to the timber that's in the navigable waterway. The bridge's history. It was originally constructed in 1903. There was a major rehabilitation done in 1949. Deck and superstructure were repaired. Repairs were done in-house in 1984 and 1985, and there were subsequent deck repairs done in 2010. The bridge itself is 212 foot long. It's considered of steel pony truss. It has 3 fixed spans and a center movable span. The bridge is founded on stone masonry abutments, which were constructed in 1903 and reinforced in 1949. Stone masonry pier under the swing span, which is what the swing span pivots on, once again originally constructed in 1903 with improvements in 1949. And then 3 steel I-beam piers, which were constructed in 1949. Those I-beam piers are steel I-beams that are driven into the mud. They were encased with corrugated metal pipe and then flooded with concrete. We don't know to what depth they were installed. The clear roadway width on a bridge between the face of guide rails is 18 feet 4 inches. The lane widths are approximately 8 foot 6 inches in each direction. That's from white line to yellow line. In the upper corners are 2 representations of the vehicles. In 1903, the Ford Model A weighed a little over 1,200 pounds. In 2010, a Ford F-150, which would be permitted to go over the bridge, weighs about 4 times that amount. The bridge has several load postings historically. In 1970, it was posted to 8 tons. In 1980, it was posted to 4 tons prior to its rehabilitation. In 1985 to 2009, it was posted at 12 tons after rehabilitation. And in 2009 to present, it's been posted at 5 tons. No trucks, no trailers, no vehicles over 8 feet wide, as well as emergency vehicles. And on April 23rd of this year, the bridge was closed to traffic due to safety concerns. Route 295 was built in 1971, the 4th lane of travel over the Rancocas Creek between County Route 626, aka Beverly Rancocas Road, and County Route 636 Creek Road. The 4th lane was specifically constructed to replace the Centerton Road Bridge. The bridge is considered substandard. The reason that it's considered substandard is because it's functionally obsolete. What contributes to the functionally obsolescence is the narrow lanes, the lack of shoulders, as well as the guide rail. Substandard features which are included on the Centerton Road Bridge are include but are not limited to: the bridge guide rail does not meet current design standards as required by AASHTO. The bridge does not have traffic warning gates or lights for use during bridge openings as required by the MUTCD. The bridge width, as per AASHTO policy on geometric design of highway, is as follows. Presently, the total width of the bridge is 18 feet 4 inches. A bridge today constructed would be a minimum of 28 feet, and the recommended would be 40 feet. The lane width is 8 foot 6 inches. The minimum would be 10 feet, and the recommended lane width would be 12 feet. Shoulder widths currently the shoulder width is about 8 inches. The minimum is 4 feet, and the recommended is 8. This is a cross-section of the existing bridge. basically details using a Ford F-150 and a sedan, demonstrates how close the vehicles come together during normal travel. What is most remarkable is the bridge is posted at a 15-mile-per-hour speed advisory. Speed advisory is a little bit different than an actual posting. If you were to get a summons associated with violating a speed advisory, they would be more or less a careless violation. The reason I point that out is there is a term called shy line. And basically what a shy line, the offset of a shy line is what a normal person feels comfortable, how comfortable I am standing next to this tripod. I might not feel comfortable because if I move my arm, I would hit it. Well, that shy line basically is the same thing with regards to fixed assets on a road. Guide rail, the actual bridge itself, any of the other features on the bridge, how comfortable you would feel getting close to that. The shy line offsets per regulation on a 15-mile-per-hour is 4 feet. 40 and 45 are the two posted speed limits coming to the bridge. They would be at 6 foot and 6 foot 5 inches, or excuse me, 6.5 feet. So in any one of those shy lines, you would be in the oncoming lane if you were so concerned about moving over. Bridge is structurally deficient. Structural deficiencies are characterized by deteriorated conditions. They don't necessarily render the bridge inoperable, but they reduce the load carrying capacity. Centerton Road Bridge currently has a 5-ton capacity, or had a 5-ton capacity before being closed in April. Things that contribute to structural deficiencies are poor condition of the deck, poor condition of the superstructure, which is the steel trusses, the low inventory rating, which is what I discussed a moment ago, which is the 5 tons, the structural evaluation of the bridge, and then a bridge sufficiency rating. I bring up the bridge sufficiency rating because there's several things that contribute to this sufficiency rating. Folks, see that 4 and well, wait a minute, why was it even open to begin with? Well, there are lots of things that contributed to that sufficiency rating. It's actually an aggregate of the 3 items in the pie chart as well as the item number 4, special reductions. It's going to be tough to read, but the items that contribute to each one of those points, what you would get a point for, in just about every one of those, in every one of those pie items, there is a detrimental contributing issue associated with the Centerton Road Bridge. After closing the bridge, when I determined that it was unsafe, I used one of our consultants that has been involved with this bridge for many, many years to perform an inspection, and I also had them have an underwater inspection done at the same time. Their findings were, based on the findings of our inspection, the bridge should remain closed to vehicular traffic for the bridge's long-term future. A major rehabilitation, complete replacement, permanent closure, or complete removal should be considered due to the bridge's age, substandard features, and numerous major deficiencies. My office concurs with that. Obviously, traveler safety is our paramount concern. Subsequently, we looked at various options moving forward. Number one is full demolition and removal of the bridge with an estimated cost of $1.3 million. Option number 2 is rehabilitate the bridge at $10.9 million. I'm showing it as an option, but I would not recommend it. Rehabilitating the bridge in its current alignment, in its current geometry, with its current dimensions, you would be spending $11 million and you would still have a substandard bridge, which would also not be considered for any funding. Option number 3 would be a new bridge, high level. By going to a high level bridge, we would no longer have a movable span. Navigable folks would be able to navigate through the channel without having to open the bridge. And option number 4 is a new pedestrian bridge at $5.6 million. Note, option number 2, the bridge remains substandard, as I mentioned a few moments ago, and likely not able to carry all legal loads. Options 3 and 4 include demolition and removal of existing bridge. The new bridge would be non-movable. The point there is that option number 1, regardless of recommendation, would be included in options 3 and 4. Ultimately, my recommendation is full demolition of the bridge, and then to seek federal and state funds to implement option 3, which is a new bridge with high level, which would not need to be operated. That concludes my report.